Hello, my name is Kevin Nguyen, and this is Lab 3, Magnetic Field of a Bar Magnet. So the purpose of the lab, we will be measuring the distance dependence of the magnetic field due to a small bar magnet N. Then we will use a computational model to visualize the magnetic field in the parallel, perpendicular, and 45-degree angle. So the equations used, we use the bar magnitude, the graphical equation of mag B versus R, then the magnetic field on axis, and then the magnetic dipole equation. So for the experiment, we first set the magnetic field in the x direction to be 0. This way that the Earth magnetic field will not interact with our calculations. Then we found the magnetometer chip in the phone, and we found the distance where the magnetic field the magnitude of the magnetic field in the x direction is 20 microtesla. We repeated this 3 times for accuracy. Similarly, we do the same thing for the magnitude of the magnetic field in the x direction at the 70, 120, 170, and 220 microtesla. And this is our data on axis. And as you can see, that the magnetic field in the x direction gets stronger the closer it is to the magnet, so it increases as your distance increases closer to the magnet. And it is weaker as it gets further away. And this is our graph on natural log of B versus natural log of R. So from our observation, we can see that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, so this is true. As it moves closer to the magnet, the magnetic field decreases. We know this is false. And the position has no effect. As we can tell from our previous data, it doesn't have an effect. So that's also false. And as it moves closer to the magnetic field increases, which is true. And this is my data on the off axis. So we have the perpendicular, Earth, X, and we ignore the Z, but yeah. But according to our experimental B at 45 degrees, we got 2.553 times 10 to the negative 5 in the x direction and 3.5 times 10 to the negative 5 in the y direction. And so for analysis, we expect that the magnitude of the magnetic field to decrease with distance, so n is negative. And since we can graph that the magnitude of the magnetic field versus r, and we'll get this equation. And so this will connect to our graph that we previously made. So you can see that n natural log r, so the n is our slope right here, and then natural log k will be our intercept. So for our calculation, so we know n is the slope, and natural log k, like I said, is our intercept, so negative 13.77. And to get k, we just raise it to the e, which will end up being 1.0465 times 10 to the negative 6. And then for mu, since we know that the magnitude of the bar magnetic field will equal to the magnetic field on axis, which is over here, we can set them equal to each other. And then we just solve for mu over there, so we isolate for mu, which ends up being k times 4 pi over 2 times mu naught. And mu naught is a constant right here, and I just plug and chug, and we got 5.232 amperes squared. And then for our code, we set up our location, our magnitude mu, and then I created the dipole of the magnetic field equation. And then I set up my axis for the parallel magnetic field. This is the perpendicular magnetic field, and this is the 45 degrees magnetic field. And this is the model. This is what happens when you run it. So the orange is the B field on the axis. The cyan color is the B field on the perpendicular, and the B field at 45 degrees is the purple arrow. And so comparing the computer and experimental model at 45 degrees, you can see the experimental is over here, and the computer was over here, and it's pretty close to each other. This is only off by 1. And what if questions? So what if you had not oriented the experiment to compensate for the magnetic north? So this will cause the magnetic field of the Earth to alter our values because of superposition. So K, mu, and N will be less accurate. And what if we stick two identical magnets together? This will cause our magnetic field to be larger because two bar magnets would make the magnet stronger and increase the field. Thank you.